Hello. In this class, we are going to explain some important questions in circles for 10th class students. So, in circles, the first theorem, you know very well, the first theorem is, for example, this is a circle with center O. If you take one point, I mean external point, you take P. So, if you draw maximum two tangents, the pair of tangents you can draw from external point, you say this is PA and PB are the two tangents from the external point to the given circle. So first theorem is saying that the lengths of the tangent from the external point to a circle are equal. I mean PA is equal to PB. This is the first theorem. This is the first theorem in 10th class. So the external point, from the external point, if you draw the two tangents, the lengths of these two tangents are equal. It is easy to prove also. Just I will explain. If you join all this AO and BO and PQ, and this is equal this because of radius, and this is the common, and before that we proved that this is 90 degrees by RHS. These two triangles are congruent. These two triangles are congruent by the congruent rule by CP/CT. You can say that AP is equal to BP. I mean PA is equal to PB. The lengths of the tangent from the external point are equal. This is one of the important theorem. On the basis of this theorem, I mean application of this theorem, there are so many questions in your textbook by in other books. But in those books questions, I have given some important questions which are given in previous exams. So how to prove these, solve these questions, just we'll discuss in this today's class. For example, if you see the first question, in the first question what is given, you see here one circle is given. This is the circle, and from an external point two tangents are drawn. This is XP and XQ are the tangents, and another tangent is drawn like this where it is intersecting the circle at R. So this is ARB also on the tangent. So XP and XQ are the tangents, and ARB also a tangent. The point of contact are different. This P is the point of contact and Q is the point of contact, and R also a point of contact to the tangents. So according to the given question, this is the center of the circle. You say this is the center of the circle. Here two things we need to prove. The first one is XA plus AR is equal to XB plus BR. XA plus AR is equal to XB plus BR. This we require to prove. This is 2 marks question. So from the figure, from the given figure, we know that XP is equal to what? XP is equal to XQ, because tangents from X. Here what I wrote, XP is equal to XQ, because these are two tangents from the external point. Therefore, according to theorem 1, this XP is equal to XQ. This XP I can write as XA plus AP, and XQ I can write as XB plus BQ. XA plus AP. So this XP I wrote it as XA plus AP, and XQ I wrote it as XB plus BQ. Now we know that what we know here, from A also there are two tangents. AP is equal to AR and BP is equal to BQ, because tangents from A, these two are equal because tangents from A, and these two are also equal, tangents from B. Same theorem we are applying here. If A is the external point, PA and PR are the tangents, therefore their lengths are equal, therefore PA is equal to PR, and B is the external point, therefore BQ should be equals to BR, because the lengths of the tangents from the external point are equal. So here AP is equal to AR and BP is equal to BQ. Then in this statement, XA plus, because of AP I can write AR is equal to XB plus, in place of BQ I can write BP. So this is the proof of the first question. First proof, XA plus AR is equal to XB plus BR. So sorry, this is R. This is R, B, R. So like this we can prove. So this is one of the important question you will get in 2 marks. The same question in 4 marks he will ask you to prove the same question. He is asking RTP is given here. What is the RTP means? XP is equal to half the perimeter of triangle XAB. Half the perimeter of XAB. Sorry, this is I wrote as XAB. So the perimeter of the triangle XAB means this is the triangle. This half the perimeter should be equals to the length of this tangent he is asking. So for that purpose, what I am doing here, we know that what we know, XP is equal to XQ, because tangents from X, or we can write just in more simple, XP is equal to XP plus XQ. XB plus XQ is equal to, again you write XP plus XQ. XP plus XQ is equal to XP plus XQ. Again, this is XP plus XQ is equal to, this XP I can write XA plus PA. This XQ I can write as XB plus BQ. Now XP plus XQ is equal to XA plus PA is equal to, already we proved that, AR. So in place of PA I can write AR plus XB plus BQ is equal to BR. You can write this is BR. You write these two in bracket and these two in bracket. It is easy for you. XP plus XQ is equal to XA plus AR. XA as it is you write, plus this XB you write as it is, plus AR plus BR. We know that XP is equal to XQ. In place of XQ, again I can write XP. XP plus XB is equal to XA plus XB plus AR plus BR. AR plus BR should be equals to AB. This is XP plus XP, 2 into XP is equal to XA plus XB plus AB. This is nothing but the perimeter of this triangle. So this is perimeter of triangle XAB. The sum of 3 sides is equal to the perimeter of a given triangle. Therefore 2, if I send 2 to that side, XP is equal to half the perimeter of triangle XAB. So like this we can prove that XP is equal to half the perimeter of triangle XAB. So here just I wrote is XP is equal to XP plus XP is equal to, again I wrote XP is plus XQ. So this is a very important statement. If you write this statement properly, then you will get easily. So this is like this only. XP I wrote it to XA plus PA and XQ I wrote into XB plus BQ. But PA and BQ, you know that there are PA is equal to AR and QB is equal to BR. Those values I substituted. Afterwards, if you see, then you will get the perimeter of XAB. So this XP and XQ both are equal because the lengths of the tangents from the point external XP should be equals to XQ. Therefore 2XP is equal to perimeter of the triangle. If you send 2 to that side, then it will be half the perimeter of the triangle XAB. This question is asked so many times. So this is also one of the important questions for 10th class students. We go for the second question. All these questions are depends on your tangent theorem only. Just I selected some questions in theorem 1. The lengths of the tangent from the external point are equal. On the basis of that particular theorem, I selected these 3 questions. In these 3 questions, these are important questions. The second question is any quadrilateral. For example, this is a quadrilateral, you say. The quadrilateral ABC, ABCD. So a circle is inscribed. Inscribed means you know that it is touching all 4 sides at one point. It is touching all 4 sides at one point. So this is point and this one point and this one point. First, what is saying is prove that AB plus CD is equal to AD plus BC. So if you observe carefully, sometimes the question will be given not like this. Prove that the sum of opposite sides are equal. If a circle is inscribed in a quadrilateral, prove that the sum of opposite sides are equal. This is nothing but same question. AB and DC, these two are the opposite sides. Sum of their lengths of these opposite sides are equal to the sum of the lengths of these opposite sides. So I want to prove that. So for that purpose, just you say this is P and this is Q, this is R and this is S. So simply you can prove that AP is equal to what? AP is equal to AS, because tangents from A. Tangent from A, the external point is A, therefore AP is equal to AC, sorry, AS, and BQ is equal to BP. Otherwise you write BP is equal to BQ. This is tangents from B. In the same way, dr is equal to ds. This is also tangents from D. In the same way, RC is equal to PQ. This is also tangents from C. So we are using the first theorem only. AP is equal to AS and BP is equal to BQ and RC is equal to CQ and DR is equal to DS. You say this is equation 1, this is equation 2, this is equation 3 and this is equation 4. If you add these 4 equations, 1 plus 2 plus 3 plus 4, what happened you see? So this is AP plus BP plus DR plus RC. Electric sides are added, and next AS plus BQ plus DS plus CQ. I added the RHS also. So you know that AP plus BP is equal to AB plus DR plus CR. DR plus CR is equal to DC. And if you see AS plus DS is equal to AD. And BQ plus CQ is equal to CB. Now it is proved. The sum of opposite sides, the lengths of the opposite sides are equals to the sum of lengths of opposite sides. So what we need to prove, AB plus CD is equal to AD plus BC. Same, AB plus DC is equal to AD plus CD. AB plus DC, these two sides are opposite. The sum of the lengths of these two sides are equals to the sum of the lengths of these two opposite sides. So this is also one of the important question. It will give in the 4-mark session, section. So first you form 4 equations, just you add it and you will get the answer. But in examination, don't write like this. You need to write what theorem you are using, why AP is equal to AS and why BP is equal to BQ. Just I wrote here tangent from A, but you write the theorem explanation, that is the lengths of the tangent from the external points are equal. So these are the tangents from the external point A. That's why AP is equal to AC, AS. So like that you want to mention, and afterwards you add the 4 equations, then you will get the result which we require to prove. So this is the second question. And this third question also very interesting, and it is also very important, and this question also asked so many times in your annual exam. So in this question also we are using theorem number 1, that is nothing but the lengths of the tangent from the external point are equal. So that theorem only here we are using. Here one triangle is given, that is triangle ABC. This is triangle ABC. So A, B, C and right angle at A. Right angle at A. So one circle is inscribed. My drawing is not proper. Okay, the circle is inscribed means it is touching 3 sides at one point. Then this is the center of the circle. So he is asking to find the radius of the circle, and 2 sides are given. Here this is 8 centimeter is given and this is 6 centimeter is given. Then he is asking what is the radius of the circle. So if you observe carefully, it is also very interesting and it is also very easy to solve this question to find the radius of the circle. So you know that first it is given that it is a right angle triangle and 2 sides are given. So by using Pythagoras theorem, BC square should be equals to AC square plus AB square. So BC square is equal to 8 square plus 6 square. So BC square is equal to 64 plus 36. So BC square is equal to 100. So BC is equal to root of 100. So BC should be equals to 10 units. I mean 10 centimeters. 10 centimeters. So I got this is 10 centimeters. Now I want to find the radius of the circle. What I am doing means here area of the triangle ABC. Area of triangle ABC. So you know that half into base into height because it is a right angle triangle. Half into base into height because it is a right angle triangle. Then half into base is 6 centimeter, height is 8 centimeter. These are 24 square centimeter. 24 square centimeter. That is the area of triangle ABC. Now, if I divide this triangle into 3 triangles by joining all vertices to the center of the circle. Now, this is one triangle, and this is one triangle, and this is one triangle. So area of this big triangle should be equals to the area of this small 3 triangles. Therefore, area of triangle ABC should be equals to area of triangle OAB plus area of triangle OBC plus area of triangle COA. So this area of triangle ABC, you know that 24, that is equal to area of triangle AOB. This triangle is again half into base is 6 centimeter and the radius should be perpendicular to the base because the other theorem is there. So this is R plus half into, in this triangle base is 10 centimeter into radius is the height plus half into, in this triangle base is 8 centimeter and height is again R. So 24 is equal to, if you cancel this is 3, if you cancel this is 5, if you cancel this is 4, 3R plus 5R plus 4R. So here I got 12R is equal to 24. Therefore R is equal to 24 by 12. Radius is equal to 2 centimeter. This is also very important question in your circles. So here one right angle triangle is given, 2 sides are given and one circle is inscribed. So he is asking to find the radius of the circle. First you find the hypotenuse by using the Pythagoras theorem. Then you apply the area formula to the triangle, that is half into base into height, that you will get the area of the big triangle should be the 24 centimeter. And after joining all the vertices of the triangle to the center of the circle, then it is divided into 3 triangles. So the sum of the areas of these 3 triangles should be equals to the area of this big triangle. That only I applied here. So base is 6 and radius is the height, and here base is 10 and radius is R, and the base is 8 and radius is R. If you apply that, you will get 24 is equal to 3R plus 5R plus 4R. So 12R is equal to 24, then R is equal to 24 by 12, then radius is equal to 2 centimeter. Sometimes here it is a right angle triangle is given, but in some questions it is there a circle is inscribed in a triangle. So you will mention this and this and this and this and this you say as X. If it is X and this is also X and this is the radius, sometimes he is asked to find the radius of the circle. But in this case, it is not possible to find the area of the triangle by using half into base into height. But in this case, you want to apply the Heron's formula, which we learned in 9th class. By using the Heron's formula, also we can find the radius of the circle. This type of question I will explain in the next class. But these are the questions, these are the important questions in the circles. These 2 questions are only depends on the first theorem, that is the lengths of the tangent from the external point are equal. By the theorem we proved these 2 questions, and the third question also very important. This is under 4 marks and this is also under 4 marks. In the first question, second one, sometimes it will be also under 4 marks, but the first question is under 2 marks. So you learn these type of questions in the circle on the basis of the theorem 1. Thank you.